All right, good evening, everybody. We're going to do now, we're going to start looking at the radar pictures that occurred that evening. And first I want to introduce myself. My name is David Hotz. I'm the Science and Operations Officer for the office. This is Tim Doyle. He's one of our forecasters. And we're going to kind of work together to kind of show you different pictures that we saw. And we're going to use a computer system. It's called a weather event simulation computer. And what it allows us to do is take events like the April 27th and 28th event, and we can archive it. So that way, later on, like Dave was talking about, as same as George, we can do research and figure out what made this event such a classic generational outbreak of tornadoes. So what we're going to do, I'm going to go ahead and sit down on this computer system and see if I can bring up some of the different images. Okay, what we're going to do first, I want to show you, if I can grab the right one here. Okay, one thing we wanted to point out to you is that this severe weather system actually started early in the morning hours of the 27th. And we're first going to look at the storm systems that occurred kind of early part of the day. And let's see if I can kind of get this thing going. This is right around, this is right around about 9 o'clock, 8 or 9 o'clock in the morning. And our first round of storms started coming in to the Chattanooga area. And what I want to do here, I want to kind of get a little closer. Okay, you can see Chattanooga, here's Signal Mountain, Saudi Daisy. And this first storm system that started coming in was actually moving northeast out of Alabama. And as the storm approached, okay, well, I have to explain exactly what we're looking here. This right here is what we call reflectivity. And it measures how much like precipitation is coming out of the storm. Now, the red represents a lot of heavy rainfall, possibly some hail coming out of the storm. One of the things that we look for in regard for tornadoes is, ever heard of like a hook signature? And it's kind of like just like a hook of your finger, but you can kind of see it right in through here. There's kind of a hook-looking signature, and we knew that this storm system had a potential of producing a tornado. So before it moved into the Chattanooga area, we already had a tornado warning out for the Hamilton County location. Another thing that we look at as well is the velocity. And how to look at a velocity, this right here is the radar. This is what we call, it's the high top radar out of northeast Alabama. And what we're looking for, the green represents, or this bluish as well, represents wind that's going towards the radar system. And this red is representing winds that's going away from the radar system. So what we're doing is inferring that there's rotation occurring right in this area. So we continue to push forward. By this time, this is right around about 9:04 in the morning, there was a tornado reported, what we call Red Bank, which is just north of Chattanooga, right around this area of Hamilton County. So that kind of gives you a feel for what we're looking for in regard to radar signatures. Now this radar slice is kind of the lower slice of the atmosphere, so we're probably only right around, let's see if we can figure out, we're right around about 5,000 feet mean sea level, or about 4,000 feet above ground level. So we're really pretty close, not too far above the surface. Okay, what we're going to do now, we're going to move on and show you some more radar images, but a little closer to home. Okay, this first radar picture we're going to look at, this is the tornado or the supercell storm that produced a tornado across the Smoky Mountain National Park. This is an EF4 tornado. It's about 170 mile per hour winds that occurred with this storm. And what I want to do, I want to show you kind of the radar signature. This is the kind of the radar signature you might see from like the different TV stations. And kind of give you a feel for what we're doing. Here's Oak Ridge, here's Knoxville, here's Greenback. Now we're down kind of like in the Monroe, Blount County area. There's Happy Valley right there. And you can see this nice looking hook signature that's occurring right across right around the Monroe-Blount County, the county line. And at this time, there was a tornado occurring right in through this area. Now, what I want to do now, I want to go back to the velocity, kind of the wind profile of the storm. Okay, now, in this case, the radar system is back up in here. This is Morristown radar. Here we are in Jefferson City. And here's our storm of interest. So the green is representing winds going towards the radar, and the red here is representing winds going away from the radar. And you can see right in through here, the definitely you can infer a good strong rotation. The winds right here at this area is right around about 62 knots moving towards the radar. And over here you got right around 30 knots going away from the radar. Over here you got winds about 65 knots moving away from the radar. So we definitely had some very, very strong rotation that was moving across the park. And again, this storm continued to move. It continued to produce a tornado from Tallahassee to all the way over to across the Smoky Mountain National Park area. The path width on this one is about 15 miles, and the width of it is about a half mile wide. So this is pretty incredible especially for being right in the middle of the park. Okay, we're going to do now, we're going to look at some of the other storms. And I know several of you guys were from Knoxville area, and I don't know how many of you guys actually had hail damage. Okay, we do have some. Okay, now we're going to look at the storm that actually produced all that hail damage that moved across kind of the Knoxville area, Alcoa area, Maryville, Loudoun County. This is the storm. Let me see if I can get the right storm here. Okay. Yep, this is it. This is the storm right here. Right now it's in Loudoun County. It is heading right now towards Farragut. Here's Farragut right there. I kind of take the radar image out. There's Farragut. Okay. Okay, now if you see the signature, look at this kind of a purplish, kind of blue signature. What that right there is showing you some very, very large hail occurring with the storm. And I know Tim's told me he was looking at the radars, kind of the algorithms that we look at for doing our warnings, and it was showing like 4-inch size hail potentially moving across that area. And so it happened, that storm did produce baseball size hail. And it continued to move, it continued to move across the Knoxville area. And also another thing that it did as well across Greenback, it produced a kind of a weak tornado. I believe it was like an EF1. About 90 mile per hour winds occurred. 90 mile per hour winds occurred with a tornado across western Greenback area. Okay, now what we're going to do is move on kind of farther on time. Okay. Now we're going to look at pretty much our strongest storm that we had the whole evening. I'm going to see if I can kind of bring it up for us. Okay, again, we're going to look at the tornado that moved across kind of the Collegedale area, right around the Chattanooga. Okay, here's the storm that was moving towards the Chattanooga area. And this was, so this storm produced a EF4 tornado, about 190 mile per hour winds. It was our strongest tornado we had the whole evening. Okay, what we're going to do now, again, right over here, right back here is our radar system. The reason why I'm using Morristown radar instead of Northeast Alabama's radar, because at this time the Northeast Alabama radar actually went down on us. So we actually started to have to use the Morristown's radar system to diagnose, even already down to Chattanooga. But you can tell if you're looking at the radar, again, this is green, winds going towards the radar, red going away from the radar. The winds are very, very strong, right around 60 miles per hour, about 60 knots. And going away from the radar was about 25 to 30 knots. And this storm continued to move right into the Collegedale area, which the Collegedale is right here. Okay. Let's see if I can bring that up. Okay, there's Collegedale. Okay, the path width of this tornado was, let's see here, it was about 37 miles long, and it had about 800 yards wide tornado as it moved across Collegedale. And eventually, Tim Troutman and George Matthews will talk more about the surveys, but this tornado produced a lot of damage across that area. I believe one of the homes was a concrete or a brick home. There were 3 stories that got totally leveled across the Chattanooga area because of this tornado. Okay, I'm also going to show, as this storm moves off towards the northeast, it also moved across Bradley County around the Cleveland area, also did a lot of damage across that part of the Southern Valley. Also, I was going to show you a tornado that moved across, let's look at the Newport. There's also we'll also do one at the Newport area. This is Newport, Tennessee. Let me see if I can bring that one up. Okay.
129.
Okay, right there is the Newport tornado. And this tornado right here did a lot of damage to one of the schools over around Newport. It was, I believe it was an EF1 tornado, about 90 to 100 mile per hour winds as it moved across that area. I want to say, do you guys have any specific storm that you would like to look at? Maybe kind of affected your area? Yeah, go ahead.
The storm that tracked from Dunlap to Spring City of the EF4.
Dunlap to Spring City, okay. That might be right there, I think.
Yeah,
that's it.
That's 9 o'clock.
Is that 9 o'clock?
Yeah.
I think that's the tornado. That's the storm that produced the tornado from the Dunlap area towards Spring City. You can tell the winds right there are very, very strong. Let's see here. The winds you're looking at right around about 65 knots towards the radar and about 30 knots away from the radar. So definitely a very strong rotation. And it continued to push towards the Spring City area. Let's see if I can bring it up. Okay, there's pretty much Spring City right there. It seems like that storm, as it moved northeast, it kind of weakened once it got to the northeast of Spring City.
It actually brought to EF1 in town and the EF4 on the mountain.
Okay. Yeah, I think the strongest part of it, once it went from like Dunlap across the mountain, and then when it went to the northeast of Spring City, it started to weaken. And I believe that's pretty much the history of that storm.
Oh, yeah, Camp Creek.
Oh, the Camp Creek. Okay.
It's 11 o'clock for 3D.
Is it 3Z? Okay, let me just change the time.
It kept changing the F factors and the
Yeah, we keep on diagnosing, look at that the damage for that area. George Matthews did a lot of the damage survey, so I'm sure he'll talk a lot about that. I'll put the pressure on George. Okay.
Okay, that's fine. You got about 2 hours.
Okay, 2 hours.
Yeah, pretty close to that.
It's pretty close.
Yeah.
Oh yeah, here we go. This is it.
Oh, you don't have to sit on it.
Let me see if I can bring in the cities.
Got it? Yeah.
Okay, we're right there. There's Camp Creek,
Right here.
and there's the storm that produced the tornado. And if you look at the winds, here's the winds. The inbound winds are right around 84 knots. So you're getting pretty close to 100 mile per hour winds going inbound towards the radar. And outbound, 35 knots. So you can see a really strong rotation occurring across the Camp Creek area. I guess we ended up measuring about 150 mile per hour winds, about an EF3. EF3 was finally figured on for that one. Is there any other specific one I could show to you, or? Oh, the Horse Creek? I think this is the tornado, the storm that produced the tornado Horse Creek. And let's see if I can bring it a little closer. Okay, there's kind of between, That's probably it. Okay, in this case here, you had winds going towards the radar right around 64 knots, and winds away from the radar right around almost 60 knots. So again, some really strong rotation that we saw with that storm as well. Oh, okay, go ahead, Tim.
Oh, and then at the elementary school in Camp Creek, we recorded 90-mile-an-hour winds right about the time that the tornado came through.
All right, thank you, Tim. And I'll show the last storm here that occurred during the night. But this is the storm that went across Washington County, Virginia. And there's the storm that produced. You can see, again, you can see a nice looking hook with it, with really strong rotation with this storm as well. So I just want to impress to you guys that this duration of severe weather started early in the morning and occurred throughout pretty much the whole entire day, and it didn't really end until the early morning hours of the 28th. So it was a very long duration. Okay, what we'll do, we'll look at the lowest scan and see how high it is. Now this, again, this is kind of an approximation.
Do we have to go back to the other?
We can just take a look at it. Here's right around the Smoky Mountain area. You're looking elevation pretty close to about 4,500 to 5,000 MSL, or right around 2,000 to 2,500 AGL. That's for that area. Now for Monroe County, most of the tornadoes in Monroe County happened right around the Tellico Plains or between Madisonville and Tellico Plains. And elevation there is right around 7,000, 7,500 MSL to right around 6,500 AGL. Yes, what we do, that's a very good question, Todd. What we do as the radar operators, we do have our radar system at Morristown, but it doesn't stop us from looking at other radars. We use high top radar, which is northeast Alabama, a great deal for the southern counties. But also, too, if we have storms, let's say like in Wise County, Virginia, kind of in northern areas, we also use Jackson, Kentucky's radar. So we use a lot of different radar systems to diagnose the storms. That's a good question. I'll go ahead and pass this on.